Let's look at the response of parallel RC circuit to triangular current input. Consider an RC circuit. Resistor is 1 kilo ohms, capacitor is 500 nanofarads. This is the input that we are feeding to the RC circuit. Its time period is 1 milliseconds and amplitude is 1 amps. Since R and C are in parallel, the voltage seen across these two components will be same. We want to find the current flowing through the capacitor and resistor and voltage across the capacitor, which will be same as voltage across resistor. Now the current flowing through capacitor can be seen as follows. At 0 microseconds, it is equal to V in into 1 minus e to the power minus t by RC. So the capacitor starts charging. I in here is calculated as I peak into T real by T period. I peak is 1 amps into T real by 1 milliseconds. Now at 5 microseconds, this is the rising slope. dV by dt will be a constant positive slope, and during the falling slope as well, it will have a constant negative dV by dt. Now at 5 microseconds, Vc can be calculated as V in of t into 1 minus e to the power minus t real minus t start by RC. T real is 5 microseconds, t start is 0, hence it is equal to 5 microseconds. Now at 10 microseconds, V in of t. V in here is equal to I in into R. So V in of t is equal to, so Vc is equal to V in into 1 minus e to the power minus t real minus t start by RC plus Vc of 5 microseconds into e to the power minus t real minus t start by RC. So here we can see that there is a charging and a discharging term because the capacitor would have charged to some initial voltage level at 5 microseconds. And similarly at 15 microseconds, but here we consider Vc of 10 microseconds instead of Vc of 5 microseconds. We can see that current flowing through the resistor, current flowing through the capacitor, and the voltage across the capacitor looks like this. During the rising slope, the current flowing through the capacitor increases and also the capacitor starts charging, and during the falling slope, the current drops down to negative value and also the capacitor discharges, but it doesn't discharge fully because the input current is still available, and hence it increases as and when the input current increases. This is the current flowing through the resistor. The same calculation is repeated in Excel. Let's look at that. This is the input current that we are feeding to the parallel RC circuit. V in here is equal to I in into R, and Vc is calculated as follows. V in is nothing but I in into R into 1 minus e to the power minus t real minus t start by RC. At 10 microseconds, this is how the equation looks like. On plotting these values, we can see how the voltage across the capacitor looks like. This is the current flowing through the capacitor and this is the current flowing through the resistor. Voltage across capacitor and resistor will look same since both of them are in parallel. Same voltage is seen across both these components. And on dividing VR by R, we get IR. Let's simulate this and check. On simulating this is the input current that we are feeding. This is the voltage across the capacitor, and this is the current flowing through the capacitor, and this is the current flowing through the resistor. Here is the summary. We can see how the input current, which is in triangular waveform, has transformed the current flowing through the capacitor and the voltage seen across the capacitor. If the time constant of RC circuit is comparable to input's time period, then it will not resemble the behavior for triangular current input. Thank you for watching this video.